Hi, this is Professor Carter. This is a continuation, the third video in the exposition of the neoclassical marginalist theory of production and distribution. Here we're going to be developing the well-behaved production function. Okay, we saw from the last lesson, the last video, that the neoclassical production function is going to say that output is going to be a function of the factor input capital and the factor input labor. We're going to assume that the production function is going to be well behaved. Well behaved is a precise meaning. It means that the productivities, that the behavior of these different factors with respect to the production of output is going to be such that we have an increase in marginal productivity at a decreasing rate. So if the factor input is going to be I, where I is equal to K over L, this says that a well-behaved production function, the first partial derivative of output with respect to the factor is positive, and the second is going to be negative, increasing at a decreasing rate. What we saw, of course, was the decreasing marginal productivities, and saw that with the concave to the origin total product curve. All right, so if this is going to be equal to the labor input, this is going to be equal to the output. This is going to be equal to the total product of labor, okay, which is going to be here, total product of labor, which is going to be there, which means then if we have the different quantities of doses, so the first dose of labor, the second dose of labor, the third dose of labor here, okay, we're going to see that each of those doses of labor is going to exhibit diminishing marginal productivity, i.e. each dose of labor contributes to the total output at a decreasing rate. Right, you can see that here. So this becomes the marginal product of the first unit of labor. The marginal product of the second unit of labor is here. The marginal product of the third unit of labor is here. Dose unit, whatever, so it's going to be here. This is the marginal product of the first unit of labor. This is the marginal product of the second unit of labor. This is going to be the marginal product of the third unit of labor, or dose of labor. And you can see that the marginal productivity is going to increase at a decreasing rate. All right, so that you have less contribution to output as you reach the diminishing margin. And the same is going to be argued for capital as well. All right, so this becomes the total product of capital. All right, this is the total product of capital. I should say total product of labor here, the capital input is constant. Okay, it's got a bar over it. Total product of capital, the labor input is constant. All right, so you're just looking at, now what happens, of course, is that we're going to be considering the general case where you're going to have a quantity of capital and labor, right? You have a two variable input production function. What if both inputs are going to be included? That gives you this nice production surface. All right, this is referred to as the production surface, and it's going to be you can think of it as the rising hill of output, right? And just to complete this scenario here, this is going to be the first dose of capital, the second dose of capital, the third dose of capital, and it's going to have the same underlying properties of the diminishing margin, right? It's going to be there, there, and there, and you can see that the margin is going to diminish, right? For each of the successive units of the capital input, you're going to have those you're going to have that decreasing margin, right? Right here, marginal product of the first dose of capital, marginal product of the second dose of capital, marginal product of the third dose of capital, and we have that diminishing margin, that property diminishing margin of productivity, right? That becomes our well-behaved production function. Now what we're going to do, okay, I'll call this, this will be 2.1, all right, because we're on the second lecture here. Okay, so this is going to be page 2.1, which is going to look at that. Now what I'm going to do, okay, I'll call this one here 2.2. All right, a little triangle under there, a little arrow under that. Okay, and what we're going to do is we're going to see the relations here. Okay, and so now we're going to take our utility surface. Okay, so we're going to take this. Okay, so you can think of this guy is going to be looking here, all right, at it, straight at it, all right, and so now you're going to have, this is going to be looked at the 3 dimensions, All right, and so you're going to have the guy looking at this corner here. I'll put it here. So you're going to now do the surface. So you're going to take each of those axes, okay, this is going to be equal to the quantity of labor, okay, this is going to be the quantity of capital here, okay, right, well, no, it's going to be here. So you can see that I take the quantity of labor and capital and I put it this, and then I'm going to make a plane. All right, so the plane is going to come from, it's going to be the, what it's going to be is going to be the floor of the utility surface. All right, it's going to be the top-down space, if you will, when we're looking at it in factor space, because you can see that the axes are going to be capital and labor, which are going to be your factors of production. So the top-down view is going to be the factor space, okay, and then you're going to have here, your output is going to be read on this axis here. All right, so these are the three, and this is going to be, I could put this here, 2, this is going to be the utility surface, all right, which is going to be here. Okay, so utility surface is going to be there, okay. We know from the well-behaved given utility function, right, that the output, let me should do this a little bit right, I have the right one, that the output is going to be, there it is going to be given by the productivity of capital and labor, the diminishing marginal product. That's going to be the diminishing marginal product of capital. All right, so the total product of capital is there, and the total product of labor is here. All right, total product of labor is going to be here. Right there. Okay, this becomes the total product of labor when capital's constant. This becomes the total product of capital when labor is constant. Okay, and then what happens, okay, is that as you have increase of capital, an increase of, increase of both the capital input and the labor input, you get that funky production surface. Okay, so it's going to be, it looks like a dome that comes down to the bottom. Okay, now what we're going to be doing is we're going to be considering, and part of the exercise is to consider different techniques that are used to produce the same quantity of output. That's going to be this idea that the technology is going to be the broad sense. So the technology here is going to be the utility surface. The techniques of production are going to be the different combination of the different inputs at the different levels that are going to give rise to that different quantity. And if we have a nice, well-behaved utility function, that's not a utility function, it's a production function, my bad. All right, this is going to be a production function. All right, production surface. All right, so it's the same difference, okay? When you get into Ferguson chapter 1, he actually does utilities, but it's the same difference. That's the production surface. So the production surface is going to be such that the different techniques of production can give rise to the same quantity of output. I'll explain what I'm talking about. So let's consider a quantity of capital. We'll call it here quantity of capital alpha. All right, so say what this is going to be. It's going to be a particular technique. All right, so this is going to be a technique of production alpha. I'm going to call that K alpha. All right, that's going to be associated with a quantity of labor. All right, that's going to be in that technique. So you can see, think of a technique of production as like a recipe. All right, so you have different ingredients in the recipe, different parts, like 1 part sugar, 2 parts salt. This is going to be K alpha parts capital, and L alpha parts labor in terms of the production of the alpha technique, or in terms of the alpha technique. So when there is a quantity of capital K alpha and a quantity of labor L alpha, we are going to produce in this technology a quantity of output, which is read on the third z-axis, that is going to go from the floor to the ceiling of that production surface. And that's going to be a certain quantity of output, which is going to be here. All right, so then you go up from floor to ceiling, and you purchase that quantity, and you produce, you produce that quantity of output, which is associated with technique alpha. So technique alpha produces that quantity of output, okay? And so I'll put this in pencil so as not to mark it up too much here. All right, so that you can see it. As you see, I construct these lectures previously so that I keep it as simple as possible. This is going to be Y alpha. All right, so that's going to be the quantity of output that's associated with that combination of capital and labor. Now, what we're assuming here, okay, is we're assuming that in the neoclassical model, okay, that there's going to be an alternative technique that can be used, okay, as we'll call that technique beta, all right, which is going to be here, and it's going to produce the same output. So there's going to be another quantity, another technique of production, all right, this one that uses less capital, okay, we'll call that K beta, all right, it's going to be the quantity of capital for technique beta. This is going to be the quantity of labor for technique beta, and you see that technique beta uses relatively less capital and relatively more labor. And what we're arguing here is that given the technology, this quantity of factor inputs, okay, is going to produce an output which is exactly the same as that of alpha. So you would say here that this is going to be the output that's associated with technique beta, and that those outputs are going to be equal, okay? Which means then that what you have here is this thing called the isoquant. All right, where the isoquant is by definition going to be equal to the locus of different combinations of capital and labor that render the same quantity of output. And so you can think of the isoquant as the slice. All right, it's going to be a slice out of the production surface, like that. And so you're taking that slice out of the production surface and you're saying, okay, everywhere along that slice, the different combinations of capital and labor, which are different techniques, are going to give rise to that same quantity of output. And we'll talk more about that in the next video, okay?